All right, do not adjust your sets. There is nothing wrong with your internet. 8.4 is all about logs. That's an old song from the Ren and Stimpy show. It's better than bad. It's good. Logs are short for logarithm with base b. Logarithm with base b. Here's what's up. Logarithm with base b is this. If we have log base b of y, this base b is like subscript, like y sub 2 and y, so it's log sub b. Y base b of y is equal to x, IFF, if and only if b to the x power is equal to y. Smith, you just wrote down a bunch of letters that don't make any sense at all. You're right. I'm going to compound a little bit worse. Put a semicolon here, and at the end of every math theorem, there's always some legalese that says, no purchase necessary, blah, blah, blah. B cannot be 1, and y has to be greater than or equal to 0. Now, this legalese thing, don't worry about that. You with that. I'm not going to stick you with that. Don't worry about that. This is the important part. Log base b of y is equal to x if and only if b to the x is equal to y. Now, logs, y'all, are just another way. It's a new notation. It's just another way to write exponent form stuff here. Now, look what happened here. We got log base b of y is equal to x if and only if b to the x is equal to y. Now, b was log base b. That's the base b here, right? B to the power of x. B to the power of x is equal to y, right? It's this weird format of going around. I've heard of people saying that, it spirals in, Smith. Look, b to the x equals y. But the spiral, I don't know. I think that's kind of a reach. But, yeah. And here's what's up. The way that we say this, I keep saying this. I want you to write it down too. This says log base b of y is x. That's what this actually says here. Log base b of y is x. Smith, I'm still not exactly sure what you're trying to say here. All right, let's do a couple of examples here. Let's talk about log form. And let's talk about exponent form. All right, let's say our log form is, let's say that we have log base 2 of 32 equals 5. All right, so this is a pattern. It's always going to be the same pattern. It's going to be this shape here. Log base 2. Now remember, base b was the same thing as base b. So log base 2, this is base 2 for exponent form. 2 to the, and you reach across to x. So 2 to the 5th power is, and then you come back to the 32. 2 to the 5th power is 32. Hey, that happens to be true too, isn't it? How about it? All right. So it's always this pattern. The base raised to the far thing and then come back to what the log is next to. All right, so try these two as well by yourself. Log base 2 of 64 is equal to 6. Let's do log base 5 of 1 is equal to 0. And if you're good at those two, let's see if you can go backwards here. 3 to the 4th is equal to 81. So if you need to press pause, give these a shot, and then come on back and check your answers. Go ahead and do that. All right, so hopefully on this one, you got 2 to the 6th power equals 64. There we go there. This one, the third one, base 5 to the 0 power equals 1. That is true as well, yeah? Now, let's see if we can follow this same pattern but going backwards. dissecting this, you should have got log base 3 of 81 equals 4. All right, logs are just another way of writing an exponent form. Now, here's the thing, I'm going to be honest with you. Some of you are thinking, why do I have to, what is wrong with this form? I've used this for a long time. There's nothing wrong with it. And you're right. However, you're going to have to give me a couple days to show you why. It's going to become apparent later. I promise. Just roll with me today. All right. Let's talk about special logs. There are some special scenarios with logs. Check this one out. How about log base b of 1 equals, excuse me, what do you think? Let's see. If we were to rewrite this, this would be b to the what power equals 1. So what do you think? B to the what power is equal to 1? Well, log base b of 1 is equal to 0. Think about it. B to the 0 power is indeed 1, right? All right, let's try another. There's one more special log. Log base b of b is, let's chew on that for a minute. B, base b, raised to the what power would be equal to b. That's right. Log base b of b is equal to 1. All right. So those are some unique ones right there. There's two more. These are kind of important special logs we need to know too. Common log and natural log. Common log and natural log. Common log says this. If we have log, well, I'll tell you this. Common log is going to look like this. It's going to look like log of x. What's missing? We're missing a base, right? When there's not a base there, there's going to be a base 10, all right? The reason why we are all about base 10 is this. We live in a base 10 world, or our numbering system is a base 10 system. Think about it. Now we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We go through 10 different digits before we add on and repeat using those digits, before we add another units thing, right? We live in a base 10 world. So that's what's up here. If you see log base 10 of x, or excuse me, if you just see log of x, that means there's a base 10 there. Excuse me. All right. Now, then there's natural log. Natural log is log base e of x. There's that number e again, right? So log base e of x, they have a special button for that, or a special symbol. Natural log, right? NL. It seems natural that it would be called the ln of x. Oh, wait a second. Well, whoever came up with natural log, they must have been dyslexics or something. But yeah, we go with ln for it means natural log. I know it don't make sense, but just roll with me, right? So again, that's log base e. All right, that brings us to page 2. Page 2. Now here's what's nice. The calculator will do common logs, common and natural logs for us. The calculator will do common and natural logs for us. For example, if I ask you, what is log of 6? All right, pull out your calculator, and your log button is right next to your 7. So press log, and see it gives you parentheses, log of 6, and it tells you that log of 6 is 0.778. We're going to go to 3 decimal places for this. So log of 6 is 0.778. 0.778. Now, Smith, how do I know that that's the case? Well, let's think about this. Let's go back. If we were to write this in exponent form, what is the base? Well, this is log base. If there's nothing there, what's there? 10. So this is log base 10 to the 0.778 power. That is equal to, oh, well, hold on. Is it 6? Let's see. 10 to the 0.778 is 5.9979. That is really close to 6. See, I won't go and steer you wrong. Don't worry about that. Log base 10, when there's nothing there, there is a base 10. All right, let's try a couple more. Try this yourself. Try the natural log of 8. And let's try the natural log of 0.1. Now, if you're looking for the natural log is next to 7. Natural log, ln, is right beneath it. So give those a shot really quick. And yeah, hopefully you got natural log of 8 is approximately 2.079. And natural log of 0.1 is approximately negative 2.303-ish. Smith, I don't believe you about this natural log thing. Well, natural log is base e, right? E to the negative 2.303. Let's put that in our calculator. Second, now check this out. We talked about the e above the division key. There's also an e above the natural log thing, right? It's e to the power of x. And what that is, that's just aching for its exponent. Put in negative 2.303. And you get approximately 0.09999. Again, that's approximately 0.1. It is base e. Approximately 0.1. Okay, so if you've been hanging on for logs so far, this is where I either lose you or make you angry. This isn't going to make sense, all right? But we're going to talk about inverses, all right? The inverses of logs. All right, just guys, I want to apologize here, and here's the thing. Right now, you're not going to understand a word of what I'm saying. But all I need you to do is to be able to do it. Huh? Here's the thing. Don't ask why, just do. I'll explain why in a few days. But right now, you just got to roll with me on this, okay? All right, so here's what's up. Let's suppose... let f of x is b to the power of x. And g of x is log base b of x. All right, I'm with you here so far, Smith. Now, if you recall from last chapter, in order for functions to be inverses of each other, f of g of x would have to be equal to x, and g of f of x has to be equal to x. So that's what we're about to do here. All right, let's start here. Let's talk about f of g of x. All right, so what would f of g of x be here? Well, f is running the show, so that means it's b to the x power. So we're going to change our x. What's going to be the exponent here? The exponent is going to be log base b of x. Okay, Smith, I'm with you so far. I just plug in g of x in for x. That's not a big deal. But here's what's up, y'all. Okay. If I have a base b raised to a log base b power, base b raised to the log base b are inverses of each other. They are enemies. Just like plus is to minus, as division is to multiplication, as sine is to inverse sine, base b raised to the log base b are enemies. They are canceling out. And what was up here in the exponent is on its own. It's just straight up x. Wait, what? I know. Just roll with me. All right? So that brings us to g of f of x. G of f of x says log base b of x. We're going to change x. What is x going to become? X is going to become b to the power of x. Okay. Now, that doesn't look anything like this, but here's what's up, y'all. If I have log base b of base b, they're mortal enemies of each other, and they will cancel each other out, leaving, again, what was an exponent is now just on its own, just x. Now, you are either confused, angry, or both, and it's okay. All right? It's okay. Just kind of flow. You don't got to know why or how or anything else. Just like I said, just flow with me on this for right now. Let's do a couple of examples. All right? We're going to simplify. Count deep breaths. It's going to be okay, I promise, all right? Check it. Log base 5 of 125. Let's start here. Now, what does this look most like? Does it look most like this guy here or like this, the second one? I would argue that it looks more like the second one because it's just straight up log. Log is not in an exponent. So it looks like this, right? But here we had log base b of base b. They had the same bases, right? Here I have log base 5 and 125. They're not the same bases. However, we are going to, this goes back to last chapter. Remember we said that if you can rewrite the base, do it? What's another way to write 125? Another way to write 125 is 5 to the third power. Right? So, what is log base 5 of 5 to the third power? Log base 5 and base 5 cancel each other out. And what are we left with? The answer is 3. The answer is 3. You with me on that? Don't worry about y or anything else. Just log base 5 of base 5, those cancel, and we're left with just 3. All right, let's try another one. How about 10 raised to the log of 4x power? All right. So, is this like number 1 or is this like number 2 up here? I would argue it's number 1 here, right? Now, because we have a log is in the exponent. The only thing is, this was base b, and we raised to the log base b. This is base 10 raised to the log base. There is no base, so what's the base? Like we talked about before, when there's no base, that's the common log. That's a base of 10. So this is 10 raised to the log base 10 of 4x. 10 to the log base 10. Cancel. Our answer is 4x. That's it. I know. Let's try two more. Try these yourselves. 8 to the log base 8 of 11x. Try that one. And then try log base 2 of 32. All right, try those two yourselves. Go ahead and press pause if you need to, and then come back and I'll walk you through it. All right, 8 to the log base 8. 8 to the log base 8 cancels. Our answer is 11x. That's it. The answer is 11x. Base 8 raised to the log base 8 are enemies. Here, we have log base 2 of 32. They don't have the same base. So, what's another way to write 32? This is log base 2 of 2 to the 5th power. Log base 2 of base 2 cancel, and our answer is 5. Yeah? Kinda, Smith. I don't like it. I know. We're going to do one more. This is the last one, and you're really not going to like this. Here we go. Log base 5 of 0.04. All right, so this is back to one of these guys, right? What is another way? They don't have the same base, so what's another way to write 0.04? That might not be exactly obvious, but we're going to go back to 3rd grade, and since this is a decimal, we're going to make this a fraction. The fraction is going to be log base 5 of 4/100ths. All right, simplify that fraction. You get log base 5 of, what does 4/100ths break down to? 1/25. All right, 25 and 5. You're starting to feel a connection, right? Another way to write 1/25 is log base 5 of 1/5 squared. All right, now, we're getting close to the same base, but it ain't the same base yet, right? What is another way to write 1 divided by 5 squared? Well, that is log base 5 of 5 to the what power? -2. Right? Remember, we got a fraction. 1 divided by 5 squared is the same thing as 5 to the -2. So now we're at log base 5 of base 5. Those cancel. What's our final answer here? -2. Man, Smith, that sucks. I know. You don't got to know why. Just got to know how. Or just got to can. All right? That's it for me. Smith out!